This is a video about the GCSE Chemistry topic of alloys. It's primarily aimed at those who are studying Unit 10 about using resources, but it does also recap the material from Unit 2, Structure and Bonding. In this video we're going to define what is meant by an alloy and explain its properties, give some specific examples of alloys and talk about what the actual components making those up are, and justify the use of alloys for a particular purpose. We're also going to look at how some exam questions might ask you to use some math skills. We'll start by recapping some knowledge from Unit 2. An alloy is a mixture where the primary component is a metal. So that could be mainly one metal mixed with small quantities of a second or third metal, but it could also be mixed with small quantities of a non-metal like carbon, as is the case in steel. Now, pure metals and alloys have different properties to one another. Alloys are harder, and that's why we use them for things like making hubcaps for cars. Because if you had pure metal, it would be easier for it to be dented by, say, a stone flying up, whereas the alloy is stronger and it's harder to dent. Now, the reason for this comes down to the structure if we look at a sort of an atomic level. In a pure metal, all of the particles are one size because they're all the same element, so all the atoms are the same. And they form these regular rows of positive ions. Now, if you hit a pure metal, say with a hammer, it's possible for one of those rows to just slide over the other rows, and therefore this makes them malleable. Now, if you compare that to an alloy, the particles are different sizes because they're different elements, so they have different atoms, and therefore the regular rows are distorted. And if you exert a force on an alloy, those rows can't slide over each other, and this makes alloys harder. We also learn in Unit 8, the chemical analysis topic, that alloys are an example of a formulation, along with fuels, cleaning agents, paints, medicines, fertilisers and foods. A formulation is a mixture that has been designed as a useful product, and it's made by mixing the components or ingredients in carefully measured quantities. So say if I was going to make some steel, I might make sure that I'd always added 1% of carbon by weight. By keeping the proportion of these components consistent, we make sure that the material that we're making always has consistent properties. In Unit 10, there are 7 named examples of alloys that you need to be aware of. So for each one, you should know its name, its components, what it's made out of, and a use for it. The first one of these is bronze, which is an alloy of copper with a small amount of tin. And this is what we used to make 2p pieces out of up until about 1992, when we decided that copper had got too expensive, and instead we were going to make them out of steel with a very thin layer of copper plated on the outside. The second alloy is brass, which is what we use to make the pins of electrical plugs. And brass contains a lot of copper and a small amount of zinc, which makes it harder. So this means that whenever you're putting a plug in the wall, you're not having to worry about bending the pins. Obviously, there's some jewellery that's made out of pure gold, and it's usually sort of very precious jewellery, things like wedding rings. But the majority of other jewellery tends to be made of gold alloys. So this is where the gold has been mixed with amounts of silver or copper or zinc. And this has a couple of advantages. One is that it makes the gold less soft, so less likely to get dented or scratched or damaged. And the other one is that it allows us to have different colours of gold. So if you've ever had something that's made of white gold or rose gold, those are alloys with other metals that have been added. We assess the purity of gold using something called the carat system. So 24 karat gold is pure gold, and then anything else you can work out as a percentage based on that. So 18 is 75% of 24, and therefore 18 karat gold is 75% gold, and the other 25% will be these other metals like silver and copper and zinc. Steels are a group of alloys based on iron, and they contain specific amounts of either carbon or other metals. We said at the start that the reason that alloys were harder was because adding atoms that were a different size was going to disrupt the layers. And it probably doesn't surprise you too much to know that as we add more atoms, that's going to make the alloy even harder. So high carbon steel has a comparatively high number of carbon atoms, and this makes it very hard and very strong, but also quite brittle. So if you sort of pushed it from the side, it might be possible to snap it. High carbon steel is used for making things like cutting tools, sort of in a factory, where we know that it's going to be quite a flat blade and it's always going to experience force in the same direction. Low carbon steels have fewer carbon atoms, and that means they're a little bit softer, and so they're more easily shaped. They're useful for making things like car bodies, where the material isn't going to be flat, it needs to be sort of bent into a different shape. And we wouldn't want something too brittle because it could snap. Stainless steels, rather than containing carbon, contain small amounts of chromium and nickel, and they're able to resist corrosion. This makes them useful for making things like cutlery, because a lot of our food has small amounts of acid in them, And so if we used pure iron, it's possible that the cutlery would start to wear away, or just that it would tarnish because of the acid in the food. Finally, you should know that aluminium alloys are very low density. And this is just, if you think about where aluminium is on the periodic table, it's a much smaller element than those transition metals that we make most of these alloys out of. And because they're so low density, they're useful for making things like aircraft. Obviously, the heavier an aeroplane is, the more fuel it'll take to fly, and the harder it'll be, but also the more expensive it would be. That's actually everything that we need to know about alloys. So now we've got 8 questions to check your understanding of this video. Pause the video and write down some answers to the first 3. An alloy is a mixture of metals, or a mixture where the main component is a metal. Bronze is a copper alloy that also contains small amounts of tin. The carat rating of an alloy that contains 75% gold will be 75% of 24, which is 18. Here's the next 3 questions, so pause the video again and write down some answers. High carbon steel is not an appropriate material for making musical instruments because it's too hard and too brittle, so it can't easily be moulded into the correct shape. Stainless steel is used to make cutlery because it resists corrosion by the acids in the food, and brass is used to make electrical plug pins because it's harder, so it's less likely to bend. Here's an example of a question which, rather than just asking us to use our knowledge from the specification, gives us some more information and asks us to use that as well. Red brass is often confused with pure copper and contains around 90% copper in the mix. Yellow brass is a paler colour and it contains up to 30% zinc. Explain why red brass is softer than yellow brass. So this is a little bit like our high carbon steel and our low carbon steel. We've got one alloy that is 90% copper and presumably 10% zinc, and one alloy that is 70% copper and 30% zinc. So the first thing I want to say is that the red brass contains more copper, or the red brass contains less zinc. In red brass, the layers of copper ions can slide over each other more easily. In yellow brass, there are more atoms of zinc which disrupt the regular rows more, and that makes it harder. Finally, here's a typical mathsy question about alloys. The picture shows an alloy that's made from elements X and Y. Calculate the percentage of atoms of X in the alloy. Pause the video, grab your calculator and see what you come up with. So, in order to work out a percentage, I need to work out the number of atoms of X divided by the total number of atoms. So I've got 2 atoms of X, and in total I've got 18. Bear in mind it needs to be the total, not just the atoms of Y. So then I do 2 divided by 18 times by 100 to make it a percentage, and I get 11%. I hope you found that a useful revision video for the alloys topic. Thank you very much for watching, and if you'd like to see more GCSE chemistry videos, don't forget to like and also press the subscribe button below.